Hey, what's up, guys? Uh, this is Chung here again. Uh, I'm still doing this LeetCode tree problems. So today, today let's talk about this number 545, boundary of binary tree. Boundary of binary tree. Okay, let's see what does this problem want us to do here. So you're given a binary tree, right? And then you're going to return a value of its boundaries in the anti-clockwise direction, right? Anti-clockwise direction. What does this mean? Okay, left boundary is defined as the path from root to the leftmost node. Right boundary is same thing, defined of the path of the rightmost node, right? The leftmost node is defined as a leaf node if you could reach when you always firstly travel to the left subtree if it exists. If not, travel to the right subtree. Repeat until you reach a leaf node. The right subnode is also defined as by the same way with the left and the right exchanged. Okay, so what does this mean? Let's take a look at this one here. At this tree here. So we have one. Oh, sorry, let me do a. Okay, so we have 1, 2, 3, 4, 5, 7, 8, 6, 9, 10, right? So so what is the left boundary of this tree? As you can see here, from 1 to actually it's a except for the root, right? The left boundary will be 2 and 4, right? Like what we discussed, like the definition that for the left boundaries, we keep going to the left until until the until this element, the last element on the left side, doesn't have either a left or or right, right? So what does it mean? So this, for example, this one 4 is the root, right? Because 4 doesn't have any left or right. If this one has another, if the 4 has another like 11, let's see, there's 11 here as it's a right subtree, then the the left boundary will be 2, 4, and 11, right? Because that's what we're doing here. As long as this last node has either a left or right side, if it has a left side, always go to left. If it doesn't have left side, we go to the right until there's no child tree of this one. Okay. Uh, and same thing for the right side, for the right boundaries here. We have 3 here. We have 6, right? We have 6, and then we have 10, right? So 10 will be the rightmost node here. And that's the left and right boundaries. And then we'll also need to do find the leaves, right? So it says we are from the left and then plus the leaves here, plus the leaves that these are all this kind of leaves, right? The leaves and the right side. Basically, it's gonna be anti-clockwise, which means it's from root left 4. I just remove it for some reason. Sorry, let me draw it real quick here. 6, 9, 10. So so the question asks us to get the result from for the left leaves and the right boundary in the anti-clockwise. So what does it mean? So from 1 to 4, right? And then that's the left boundaries, and then go to the leaves 7, 8, 9, right? And then 10, right? 10 and then back to 6, 3. That's the result, right? The question wants us to do. So how can we think about this question, right? I mean, we one way is we can get we just follow the that description. We get all the for the left boundary traverse. We get all the node for left boundary traverse. So it'll be 1, 2, 4, right? And then we get all the leaves. Leaves will be 4, 7, 8, 9, and 10, right? And then we get all the right boundaries 10, 6, 3, 1. But notice that so the leftmost node and the rightmost node, they will be they're also part of the leaf set, right? So in that case, if we get those three sets, we just combine them together. We will need to make check. We need to make sure this leftmost node and the rightmost node doesn't get added twice. That's one way, right? And another way is the to avoid checking duplicate is when we traverse for the leftmost tree, right? We stop here, right? We stop at 2 here. We basically we add 2 here, and then but when we see 4, we don't add 4 because we know 4 will be our leftmost tree leftmost node, so we only add 2. Same thing for the rightmost node, right? So we add from 3, 6, and when we see 10 here, we don't add it. We just stop at here, and then we'll be having 2 and 10 here. So in that case, we don't have to worry about this like duplicate thing, right? We just stop at one level before. And then we'll have 4, 7, 8, 9, 10 as the leaf node, and then that should work. Uh, okay. Yeah, so basically that's the basic logic here, and let's try to implement this thing here. So first, so basically we're gonna define three helper functions. First one will be like DFS for the left boundaries, right? We can call it leftmost here, right? Node, and then we'll have another one, DFS rightmost. Sorry, leaves. We'll do a leaves first, second, because that we won't do it anti-clockwise, right? And then it's gonna be another one, DFS rightmost, right? Same thing for the node. Okay, so let's write the main structure here. So assuming we have those two nodes, right, and then we're gonna have sorry, assuming we have those three helper functions, and we'll have a like result to keep the final result, right? So okay, of course the final result, the first one will always be the root node, right? Because we're always starting from the root, so we add the root value to the result first, then we do what? We do a left side traverse, right? We traverse to the left side. And here, I prefer to do a check here. So basically, if the root dot left, if there's a left, right? If there's a left, I do the check here. You can also do the check inside here, but in my case, I prefer to do the check beforehand. So, and then we do a DFS, right? The leftmost, right? Mm, root left, right? And then for the leaves node, it's fine because we don't care about the leaves node. We just sorry, for the leaves node, we don't care about the left or right. We just do pass the root node, basically DFS leaves right? Pass the root to get all the leaves node, and then we will traverse on the right side, basically, right? DFS right most gonna be root dot right. So in the end, we simply return the result here. Yeah. So that basically that's the main structure of our code. So now it just comes down how can we implement this left side uh, leftmost traverse here, right? So the main part is if node, right? If node has a left, right? If node has a left one, we always go to the left. If there's a node has a left, we always go to left uh, because we want like the definition of the leftmost node. We always try go to left first, right? Node dot left, and else then we go right, right? Else if basically else if node equals to right, if there's a right side subtree, we go to the right basically, right? Remember, notice here we do a if else here because if there is a left one, we don't need to go right, right? We always try to go left as much as possible. If there's no left subtree, and then we go right, right? So that's why we have if else here. And so here, right? So remember, while we were traversing the left subtree, leftmost node, we'll keep adding the result to the to our final result, right? Node value here. Sorry. And remember, we want to stop at 2 here because so we will not add 4, right? So what do we do here? We do a check here. So if node dot left, if the node doesn't have left, and basically if this node is a leaf node, right? And not node right. We just stop here, right? See, otherwise, we'll add this leaf node. For example, here we have 1, 2, and 4 here, right? So once we reach 4 here, and we see 4 is a leaf node. Basically, it doesn't have a left or right and right subtree. So we just simply return before adding it to the final result. So in this case, so once this is done, we have 2 and we have 2, right? Now, so basically, so that's it for the leftmost helper. So now we want to write this like uh, leaves here. Okay, so for the leaves node, we can there are like I think not more than one ways we can do the traverse. We can either do a pre-order or in-order traverse. Uh, Yeah, because I think for the leaves node, we just need to traverse all the way down here. We don't want to do a post order because remember, uh, we want to output the tree node from left to right, right? As long as the sequence traverse sequence from left to right, it's fine. So basically, either pre-order or in order will give us that sequence. If we do a post orders, the leaves node will start from right to left, which we don't want, right? Yeah. Okay. So let's do a pre-order traverse here, right? Pre-order. Um, Pre-order means we traverse left side first, or all the way to the left, and then to the middle, and then to the right, right? To the root, to the right. Okay, so uh, first not node, right? We just simply return, right? That's the basic here. If and then we do we do a DFS. DFS we do a recursion traverse here. Node dot left, right? And then we do something here. Do something. And then we traverse to the right side. Right? Do something. So what are we doing here? So we check if this node, if this if the node doesn't have a left, or if this node is a leaf node or not, right? If not node, not like what we discussed. what we check in the leftmost method here. Node dot left, right, and not right, not right. Then we append it, right? We append this one to the we append this node to the to our final result because we know that's one of our leaf node dot value here, right? But remember here, we need to do another check here. We need to make sure this node is not a root node, right? Let's assume basically assuming we have a let's say we only have one node here. Let's say there's one. This tree only has one node here, and we're passing this root here. And this one doesn't have left or right, but we cannot treat this one as a node because root is a root. Root is not a leaf node, right? That's why we need to check um, the root node here. So if node is not root, right, and it's a leaf node, right? We're done with this one here. Same thing for the rightmost thing. So we can just copy most of the code from the leftmost one. Uh, okay, first we stop, right? We stop it, and then here if node, but remember here we have to check right side first because we're going to the right first, right? All the way to the right and the rightmost, right? And then node right, right? If there's not a right subtree, we'll go to left, right? We'll go to left. We go to the left, right? But then remember, so here's one thing you need to we need to pay more attention here. So basically, remember once we reach 10 here, we start from we start traversing the right side, right? But remember, we're traversing from top down, right? Top down here. So we'll get 3 first and then 6, right? But instead, we want to add 6 first and then 3. Basically, it's like a reverse traverse, right? I mean, they're like a a easier way you can do it. You know, you can like define a template array somewhere here. Like instead of result, you can define another one like to store. You can use the same thing. Basically, you can just keep adding these values here at the beginning of this like rightmost traverse. Then in the end, you just reverse that sub arrays, and then you just append that reverse array to here, right? That's one way of doing it. And the other way of doing it is we don't have to use like a helper array. So instead of adding this result at the beginning of of each traverse, we can add it at the end, right? So add append, right? So that's how we do a reverse traverse that we added here. But in the end, that in that case, basically when we get all the way down here, right? And then basically we'll add 6 first and then 3, right? Yeah. Okay, I think yeah, I think that's all we need to do here. Let's try to run it. Cool. Oh yeah, it's always the sanity check here. Um, if not root, simply return empty array. Mm, okay, let's see. So it has to be, oh yeah, I know. So here, yeah, remember here we are using the same leftmost sub helper function. Yeah, here, yeah, same thing here. Because we're using the same recursion functions, yeah, that's why I got confused here. left, left, right, and right, right? Typos. All right, cool. Pass. So just to recap real quick, we do a leftmost traverse to get all the no, left side boundaries, and but we stop before the leftmost node, which is also part of the leaves node, so that we won't add this node twice. And once the left side is finished, and we will get the leaves node from left to right. You can use either pre-order or in order traverse. Here we're using a pre-order, and then the last part is to to traverse the rightmost boundary, rightmost node to get the right boundaries. But in this case, we'll be adding the values at the end so that we'll get the result from bottom up, right? And here, yeah, some small things you need to take into account. Don't treat the root node as a leaf node. And then we add root first, do this, and then finally we just return the result. Okay, cool guys. I think that's it for today. Thanks for watching. All right, see ya.